Hello everyone. For this tutorial video, I'd like to explain how to make realistic acceleration for your car, instead of the way it suddenly stops like it does now. And in fact, if you watch the tutorial video on tower defense games, it uses the same exact general trick, namely using trigonometry. So we would use the same exact replacements, namely we would replace the move 10 and negative 10 steps with separate x and y components, like so. We now confirm this works. And indeed it does, although you may have already noticed that the conditions for pressing the up arrow and down arrow are the same exact, so it moves in the same exact direction, which we do not want. We want it to move in opposite directions. So we would fix this by multiplying by -1 in the down conditional. Like so. And we playtest as usual to make sure it actually works. And although we now have it moving in separate directions, it moves backwards compared to what we want, i.e. it moves back when we press up, and it moves forward when we press down. However, a quick fix without having to rewrite any of the equations is to simply swap the conditions in the if statements. And it works. However, it still stops suddenly as soon as you let go, which is not realistic for racing games, so we will fix that. In particular, we would have a variable where we store the speed in both the x component and the y component, so two separate variables. So we would next use this variable in the code by multiplying by the appropriate components. And then we would do the same thing with the other key. However, even though we use the variables in the scripts, we have not specified what the variable actually should be in terms of a value, so we should do that now. And we now test to see if it works. And indeed, it does. If we change the variable to a greater number, it should move at a faster speed. And indeed, it does a little. So now that we have a variable that we use to control the speed, we can make the car accelerate by adding to the speed as long as the key is pressed. Like so. Testing to see if it works. And indeed it does. The longer you hold the key, the more dramatic the speed becomes. However, you may have noticed that the speed does not go back down as soon as you let go. Because of the fact we do not have a script to reset the speed as soon as you let go, which we will add now. So we replace our if statements with if-else statements instead. So that it checks that as soon as you let the key go, the speed will become 0. Like so. We update the other movement script when you press the up arrow key using the same exact logic, although we check if you press the up arrow key instead in the condition. However, what becomes problematic is that because these both are setting the speed to 0 when you let go, they are competing with and overlapping each other. So one cancels out the acceleration of the other and vice versa. A solution to this is to combine these into one big conditional, so that it will set the speed to 0 if you neither press the up nor down keys. So we will proceed to do that now. And indeed, we get our acceleration back in both directions. However, we are not fully done with the mechanics yet, as we still have to make it realistically slow down and not stop with a sudden jerk. So we would instead revise our script so that it constantly changes the x and y components and not simply changes it as soon as you hold the key down. Like this. So now, the scripts for changing the motion and the up and down conditionals would simply update the speed and not the actual motion of the player. And we would also update the variables that control the speed according to the mathematical functions, rather than the x and y positions themselves for organizational purposes. However, the if conditional no longer works the way we intended it to, for checking when the speed is 0 and making it 0, because it is a sort of chicken or egg problem, where the speed must be that exact value in order for the conditional to be true. And the sine and cosine functions give messy decimal numbers that often go right past 0. So we can simplify the code somewhat so that this particular if-else statement is no longer needed. However, with the way the code is now, if we were to playtest it, the player would go right off the screen because the number increases so dramatically when we update the x and y position by the variables, which we can see for ourselves if we check. So our solution is to multiply with the change x and y components by a decimal amount. So that way it increases it only the fraction the way it does now. Like this. Unfortunately, because the number is so large, we will have to keep reiterating smaller and smaller decimals until we get a satisfactory result. Now that we have gotten the character to move realistically, we can move on to fixing some of the issues, such as the character going off screen, or the character not moving when you press up and down at the same time because of the clashing scripts. Next week. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos. and follow me on either Facebook or Twitter for more content.